Hello, I'm Pavel Odintsov. I'm author of FastNetMon and CTO of FastNetMon Limited. Today I'm going to go into a little bit more detail how actually DDoS attacks are implemented. So in many cases, when we talk about serious large-scale DDoS attacks, they are implemented in quite a sophisticated way. For simple attacks, when I say simple, okay, let's talk about boundaries about power. Let's talk about something like attack in range of about like few gigabits of capacity or few hundred thousands of packets per second. What is required to implement this kind of attack? Literally just buy a powerful machine from cloud provider and you will happy to run it. That's very sad, and there are plenty of companies on market. They're definitely very shady companies, and in many cases they even can claim that DDoS from their service is allowed. It's extremely upset, extremely frustrating to see this kind of offerings, but we have them unfortunately. So, and typically in many cases you actually can read this kind of service and bad guys can attack your company. But in this case, scale of attack will be limited. Not so much you can do from one machine. It may be a very powerful machine, it may have lots of network capacity, but for you or your ISP, it will be very simple to pin it down and raise complaints to their upstream and stop this malicious traffic and stop attack from happening. And let's move a little bit next. So then let's talk about attacks on scale of maybe starting from 10G and maybe from million of packets per second. And this kind of attack, it makes it extremely complicated to run it from small set of machines. Some bad guys that just cannot rent some dedicated service or virtual machine and start attack against you. It doesn't work this way, and they need to be more complicated, more well prepared. And that's how we end up to a service called booters. And again, unfortunately, there is a clear market where you can use your credit card to buy DDoS. Even more shocking that it starts from something like $5 just for runs. You usually can run an attack for a few dollars. It's just impossible to grasp, really. It's so frustrating to see this kind of scale, because problem is it's $5 to start attack, but to defend attack you need to invest at least tens of thousands or hundreds of thousands of dollars. And unfortunately, this game of shield against offense, we are failing, because it's simpler and cheaper to run attack than defend it. So, and one of the goals what we are working at FastNetMon is to make it more affordable and make defense more understandable for people, that you don't need to buy service, don't need to buy expensive equipment. By deep understanding what DDoS attack is, you may defend it cheaper, faster, better. And how this kind of service actually works. That's why in many cases people call volumetric DDoS as amplification. What does it mean, amplification? Amplification. Or it may be not only amplification, it also may be called reflection. Again, amplification, reflection. What's going on here? It's but in most of the times just synonyms about volumetric DDoS, or because it's more about logic and approach which is used to generate a serious amount of volumetric traffic. What does it mean, amplification? Amplification means you need to amplify. So again, let's imagine that attacker, they own single machine, again, oriented from shady ISP, which actually allows bad things like spoofing or DDoS from their service. Again, it's sad, but you know. And they need to generate at least 10 gigabits of malicious traffic against victim. As I highlighted before, it's impossible to generate from, say, single machine It's really tricky. And if you can do it for like 10th G, and then again you want 100G attack, it's definitely impossible to generate from single machine. You just literally cannot. But what we can do, what they can do, they can amplify. That's why it's called amplification. How? So, how it implement that? It's instead of attacking your service directly from this machine in shaded data center, they send packets to some different service. What kind of service? It's not service for bad guys to like pay and amplify attack magically. It's just public network service exposed to the internet. You may guess one, DNS. DNS is one of the very popular DDoS amplification approaches. How it works? So instead of sending traffic straight directly to your network from data center and from servers they own, they send it to hundreds of thousands DNS servers across the planet. And why? What is the point? So we are trying to knock down specific servers, like victim, and instead we are trying to send traffic to hundreds and thousands of machines across the planet, which is completely irrelevant to victim. Like, what is the hell going on? Like, why? But interesting thing is, the main point of amplification and different protocols, different approaches, they have different amplification ratio. What is ratio? Ratio, it means how much, what kind of amplification you may expect. What does mean amplification? We're talking about sound? No, processing? No, we're talking about network. Okay, let's imagine you send one packet in length 100 bytes. And if service, like DNS, can multiply it by 10 and send to victim 1000 bytes. What does it mean? It means that we have amplification ratio 1 to 10, or just simply 10. And how is it possible? It's possible because of some, I would not say issues, but I would say design decisions or features of specific protocols like DNS. How it implemented? So, attacker side, they send packets to many DNS services exposed to public world across the planet. In their request, they may have something like, okay, let's give me in IP addresses for service google.com. And again, it's expected that for Google.com we have around like 4 IP addresses. But again, a request will be smaller than answer. And in many cases you may find different DNS records which in for simple and very short request, DNS request, which is literally just like around 10 bytes. Please give me a records for google.com. And in exchange, it may answer sometimes tens or even more IP addresses. Which means for your very small request around 10 bytes, of course in terms of network it's not 10 bytes, it's like at least 70, we may receive thousands, which is great, which means like having like some limited capacity of around 1G from shady data center, we can multiply it by 10G, and that's how it works. But again, stop. We send packets to some third-party DNS service, which just amplified them. But how it will actually reach attacker service, victim? It will, because when attack starts, when attackers send this kind of so-called amplification requests to DNS resolvers across the planet, they change source IP. instead of saying, okay, it's me sending this request. Because in this case, every single resolver they send requests to will respond to them. And it will usually knock them down, which will be great because it will eliminate attacker and eliminate probe. You will have no DDoS. But what happens in reality? So in reality, the attacker will spoof and fake source IP, and instead of using their own source IP, they will provide victim source IP, which literally means that when legitimate resolver receives request, please give me every single DNS record for domain.com. And okay, we can do it, but they have victim's IP address as client, and they will do it and will send every single piece of data they have to them. And again, considering number of it may be 1,000, maybe tens of thousands, hundreds of thousands machines involved in this amplification, it may generate tens gigabits easily of capacity, or sometimes it may generate hundreds of gigabits. That's why it's called reflection or amplification, because in this case we amplified it significantly. And for DNS protocol, amplification rate is not that high, but there are so many protocols like NTP or SSDP which offer way worse amplification level, or memcached, and it may be 1 to 1,000. And can you imagine, by sending by every single packet sent by a victim, maybe thousands of packets sent directly to a victim from service which is being used as amplifier. That's so dangerous, and unfortunately not so many options we can do, because I have so many public services which can be used for amplification, so many, and literally there are no option to knock all of them. Some of them definitely have configuration issues, but some of them are just perfectly legitimate service, and that's how protocols like DNS or NTP or TCP they are implemented. They are vulnerable to amplification by their nature, which makes this kind of attack it's almost impossible to eliminate completely. Of course, local authorities and global regional internet registries, they work hard to convince people like you need to upgrade your DNS service, you need to apply this kind of configuration to make it more complicated for attackers to use your service as amplification. But it's almost impossible to change and fix all of them. And that's the reason why we need to be very well prepared, what we can do, how we can defend. But for now we have clear understanding how attacks work and how you can actually understand, like fight them better by clearly understanding how it was started. What is main outcome for what I told today? Main outcome, if so many companies, so many people, they try hard to block IP addresses which attack their network in attempt to stop attack. And again, in case of amplification, it will not help, because next time attacker will change vector, next time attackers will change amplification vector from DNS to NTP, and this will be same. And what you're actually doing, you are literally block legitimate services. Even worse, recently we had incident related with micro-tick routers, because what actually happened, attackers, they created botnet from hacked micro-tick routers, and they started the attack against so many services. And many companies, they tracked down IP addresses of micro-tick routers and blocked all of them. And then they started receiving like lots of requests like, why your site doesn't work for me? What actually happened? Because micro-tick has customers behind them. So it's like your router in your office network is attacking some third-party service. And as outcome, this service blocks your router, which it means it blocks you and every single person, your like office building or your just office or even your like neighborhood. which is not what you're looking for, because that's the reason why you need to be very careful about why this specific service must be blocked. And that's why we advocate for using BGP flow spec to block only specific malicious traffic, which is definitely malicious, which is definitely here to disrupt your network. And instead of just, okay, let's block a list of IP addresses and attempt to attack us, no, it will not. And so, stay tuned and listen for next podcasts and next videos about what we can do and how we can efficiently stop DDoS attacks.